This topic is an introduction for those who are just starting their immersion into the world of machine learning and suggests implementing your own linear regression. Today, I will implement linear regression, namely, create individual functions. Combine all the functions into one class and evaluate the obtained result on a dataset. As a test of the created functions, I will use the value according to the data of car sales on the secondary market of Moldova. To begin with, I import the necessary libraries. After that, I will read the file into a data frame and create lists containing the names of the categorical and numeric columns. The implemented linear regression will be run only on the columns year, distance, engine capacity, and the column price in euro, which is the target variable, and the rest of the columns are coded categories. In this implementation, we'll conduct linear regression solely on the numerical columns, totaling 4. Our target variable model is defined as y, where y represents the predicted target for the ID record, x denotes the input parameters for the ID result, w is the set of weight parameters we aim to optimize in the model, and epsilon represents random residual values. Thus, our regression model will take the form like that. First, let's divide the data into training and test data, as well as normalize them. Also introduce the regression consumer function as the square of the difference between the target values and their predictions. Let's test both functions, and according to the graph we can see that when the same values of the target variable and the predicted value are given to the input of the loss function, the result of the loss function will be 0. If the values deviate, there will be a quadratic error. We note at once that we need not only the loss function itself, but also its derivative on the set of optimized parameters w. We will perform optimization using the gradient descent method. In essence, this method boils down to a sequential iterative recalculation of the values of weight parameters back to the values of the error gradient in the direction opposite to the direction of error growth. Let us denote the iteration number as t. Then the expression for updating the weight parameters can be written as formula. Now let's update the weight parameters. In addition to training the values of weight parameters, it is necessary to set their initial values, that is, to carry out the initialization procedure. Such a procedure can be performed using small random values. We will also create a training procedure. The procedure will repeat the process of recalculation of weights by the gradient descent method a given number of times epochs. Also note that in practice we can update the weight parameters not for each individual value I, but for the whole set of such values. Then a more correct expression will look like such as, where n is sample size. Now we see how can we test the learning function. As the number of epochs increases, the value of the loss function tends to 0. To consider the accuracy of the function prediction, I will use the metric coefficient of determination metric. If you are interested in more information about metrics, you can check the link in the description for details on regression metrics. Let's see how our answers compare to the real ones. In practice, at each epoch, not the whole sample is considered, but only some part of it, the so-called batch. Now let's merge all our parts into one linear regression class. When merging, we will make 2 additional modifications to our model, and it is important to see the weights. After introducing additional modifications, it can be seen that the final metric has increased. Today, I tried to highlight the main linear regression functions, as well as their implementation and testing on a given data set to better understand their operation. This was followed by combining all the functions into a single class and a final evaluation of the performance of the class. To sum up today's topic, we can say that we have covered various aspects of linear regression. We've explored how linear regression can be applied to real-world datasets to predict outcomes and understand relationships between variables. Additionally, the advantage of linear regression is its simplicity and interpretability, but the disadvantage is that linear regression cannot handle complex dependencies in the data. You can explore the code and link to the GitHub repository in the description containing the complete assembly of the linear regression class. Thanks for watching.